blur out my background on WebEx, can I?
There are different options for changing the virtual background. I just can't remember. Oh, there
Yeah,
is
you
an option.
can.
Yeah.
If you go to the right of your video button, there's a little arrow. If you click that, the second option should be blurred.
Okay. Yeah, I see that now. It's downloading something.
And Bella, I noticed, I think I saw something saying that it is recording, but we still have 5 minutes, right?
Yeah, I just turned it back on so that I don't forget.
No worries. But currently it's just us, right?
Everybody can see it. Do you want me to put it into practice session?
Maybe just for a few minutes.
For sure.
Okay, so welcome back everybody, and we hope you managed to enjoy your break, have a little bit of a stretch. So we had 2 sessions to look forward to this afternoon, and our first speakers are Laura Bredhal and Jenny Hirst, both with the University of Waterloo. And Laura, as you know, is the Bibliometrics and Research Impact Librarian there, and Jenny is a Library Reporting and Assessment Analyst. And again, I should be mentioning that all speakers have full bios in the full program. So if you wish to learn more about Laura and Jenny, check out their bios there. And I will pass things over to Jenny. And thank you to you both.
So thank you, Shannon. I'm actually going to get things rolling today. So I'd just like to thank the host of the BRIC conference for inviting us to share the analysis that we're going to be talking about today. And as Shannon mentioned, I'm joined by Jenny Hirst, Library Reporting and Assessment Analyst from the University of Waterloo, who will be describing the Chord charts in the second half of this presentation. So could just go to the next slide. Okay, I'd like to start off our presentation by acknowledging that I am living and working on the traditional territory of the Attawandaron, Anishinaabeg, and the Haudenosaunee people. My home, as well as the University of Waterloo, is situated on the Haldimand Tract, which is the land promised to the Six Nations and includes 10 kilometers on either side of the Grand River. I'd also like to draw attention to the land back campaigns in this region that are actively seeking support from our community to help raise funds for legal defenses needed for the 32 and growing active land claims that are in the negotiation process. So our agenda today is pretty straightforward. So I'll begin by describing how I developed the data set for our analysis of the interdisciplinarity at the University of Waterloo. In this, I'll also attempt to illustrate some of our logic in choosing this method. Then I'll pass it over to Jenny, who will describe how she created the chord charts for this analysis. So this is a high-level description of the data that were exported to and processed in Excel. The data set is based on Scopus data over the years 2015 to 2019 and was exported from SciVal in March of 2020. The data is also based on the All Science Journal classification, which I'll refer to as the ASJC or subject classification from here on out. We use scholarly output counts for this analysis. So next slide. Jenny's navigating for me. She's doing a great job. Okay, so we were interested in UW publications that overlapped 2 subject classifications. So for example, the overlap between, we'll go back. Yeah, so for example, the overlap between the AGRI circle, so one of those yellow circles there with the big AGRI initials there, and the arts classifications represent the number of documents that have Agri and Arts classifications. So this illustration also shows that there would be another data point representing the number of documents that had the Agri classification and the BioC classification. So this was then repeated. Oh, no, you can stay on that again. Sorry. So this was then repeated for all 27 subject classifications, resulting in a 27 by 27 cell matrix table, which I'll be showing you in a minute. However, I first thought it would be important to describe why we chose to define interdisciplinarity using the Scopus subject classifications, or the ASJC. So you'd probably agree that it's difficult to define what is meant by interdisciplinarity, and I appreciate this has been mentioned a couple times during this conference already. So is it based on author level data where we might measure who's working with who? Is it based on reference level data, measuring who's citing who? Is it based on keyword level data, measuring the crossover between research topics? Or is it based on journal level information, measuring journal or article classifications? And these are just to name a few of the possible options in measuring interdisciplinarity. So because we were interested in beginning with a high level analysis that represented the institution more broadly, we decided that the Scopus subject classifications could reasonably represent interdisciplinarity at the broad research level. So why use the ASJC? Firstly, it is a classification system, therefore it allows there to be standardization across all the documents. And secondly, the documents can be classified in more than one subject, therefore allowing us to identify the intersection of research areas. We also chose this method because of how readily available the data is using the SciVal system, meaning that we didn't have to use any other data sources to compile the data. And this really was relieving ourselves of the often tedious task of compiling multiple data sets. So I'm sure that there are more sophisticated ways of measuring interdisciplinarity. However, it was decided that this process, although not as granular as some, was still able to give us some helpful insights into the high-level interdisciplinarity at Waterloo. And in the words of one of our presenters earlier, this is a low-risk data set as it is for university-level information. Okay, next slide. Thanks, Jenny. All right, so this is just a snapshot of the resulting matrix table that I was able to create using the SciVal data. So the pink to red boxes are our initial attempts at creating a heat map visualization using Excel. So each data point on this matrix table represents the number of documents assigned to overlapping subject classifications. So for example, using the intersection of the Agri and Arts from earlier, we can see in the top left corner of this matrix table that there are 14 documents that have both of these subject classifications. So we found that the heat map didn't really help us in our interpretation of the data, as it was still very difficult to see the relationships between two research areas outside of, as you can see, those really strong relationships represented by the deep red colors, but anything in between seemed to be very hard to interpret. Slide. So this is our second attempt to visualize the data. However, as you can see in this chart, although it sort of looks pretty, it doesn't really add any level of clarity to the interdisciplinarity question. It's very difficult to see the relative interdisciplinarity of the various subjects at Waterloo. And it is there for this reason that I approached Jenny with her R coding skills to see if we could use the Chord charts to supply a better visualization of this data. All right, next slide. Okay, so I'll now describe how we created this data set. Okay, there are three main steps to creating the matrix table. The first of these was to create 27 separate publication sets that represent the UW publications from 2015 to 2019 that fall into each of the Scopus subject classifications. So this slide is a screenshot of these publication sets, which are stored in as separate entities within the MySciVal workspace. So if you're familiar with MySciVal, that's where these are sitting once they're created. And this allows me to add them to the other SciVal modules for analysis. Next slide. So this is a little bit of a how-to presentation in comparison to some of the really great presentations earlier that talked more about responsible use of metrics and whatnot. So bear with us. So to create these publication sets, I used the overview module in SciVal and filtered the data by the Scopus subject classification using the all subjects area filter seen in the middle of the slide inside the yellow box there. So at the center of the screen. So next slide. So once the subject filter was applied, I selected the view list of publications. So that's in the yellow box under their under the scholarly output metric. So as you can see here, there were 912 publications for agricultural and biological sciences on the date that I took this screenshot specifically. So next slide. Okay, so once I was in this publication set box, I was then able to save the publication set as a separate entity in SciVal. And then I had to repeat this for all 27 classifications. So at this point, once I had all of the publication sets created, I could have chosen to download each of the publication sets and look at the intersection of the subject classifications using Excel. However, I was really determined to do this within SciVal if possible, as I felt it would ultimately save me from having to compile the data and counts in Excel, which I think we can all agree can sometimes be tedious. Next slide. Okay, so this brings me to the second step. This step created the interdisciplinarity data and involved getting the 27 publication sets into the benchmarking module in SciVal. So you can see the publication sets selected in the left-hand panel over there in the window, which means that they're active in the chart in the middle of the screen there. So for this, the scholarly output was selected as the metric on the y-axis and the publication years 2015 to 2019 on the x-axis. So next slide. All right. At this point, I selected the subject classification filter again, as seen at the top of the page in the yellow box. And I just want to highlight that the subject classification filter was intentionally used twice in order to create the intersection of the two subject classifications across all the publication sets. So once this was done, the data was then exported to Excel. So the next slide. So this is a snapshot of the export from one of the 27 subjects. So as you can see here, the number represents the number of documents with the overlap in the corresponding subject. So this is the AGRI subject classification for this data set. Okay, next slide. Okay, so you probably can't see this very well, but the point of this is that this process had to be repeated for each of the 27 subject classifications and resulted in the data being compiled into a matrix table as shown here. So as I said, I don't really expect you to be able to read the data in this slide, but I do want to point out two observations. Firstly, how difficult it is to see any relationship in this visualization. And as I mentioned earlier, you can sort of see those strong relationships, but a lot of this sort of in-between stuff is really hard to see. And also that if you have a very keen eye, and I've highlighted a few of them there in yellow, is that all of the data points are duplicated in this visualization. So this is at the point which I'll hand it over to Jenny, and she'll explain how we handled this duplication while generating the chord chart visualizations in R.
Welcome everybody. I just want to briefly apologize. My webcam has decided not to function right now, but in light of everything else running smoothly, I've decided to just not worry about it. So just pretend there's a friendly face on the other side, and we'll go from there. So I'm going to be talking about how we use the chord charts to visualize the cross-disciplinary collaborations that are occurring in the publication lists that Laura pulled out and wrangled all for me, which I was very much appreciative of. So let's start off with choosing the right data visualization. As Laura showed earlier, there are some options in Excel such as heat maps, bar charts, but with this data set, we really want to highlight the relationship aspect. So we've decided to go with chord diagrams for this point. And as you can see on the screen, the basic definition is that a chord diagram represents flows or connections between several entities, also called nodes. Each entity is represented by a fragment on the outer part of the circular layout. Then arcs are drawn between each entity, with the size of the arc being proportional to the importance of the flow, or in this situation, it's more proportional to the weight of the relationship. So if you take a look here, this is just an example chord chart diagram from the R documentation, where we have the nodes, which is our headings along the circular plots here. And in this case, in an R chord chart, this will be the ASJC subject areas. And then we have the arcs, which once again in this visual is simply the black, blue, and green relationships coming across the chart. And just kind of a note again on the emphasis of right. This is what we chose and what we went with. But chord charts can be a very complicated visual to understand, especially if you're not really familiar with them. So just kind of take that in mind, where if you are choosing to use one, it's good to have it in a situation where you have a bit of story time to tell to help explain the data and the relationship. It's not necessarily the best visual to just pop up there on a website without any explanation. So just something to keep in mind. The chord diagrams are available using several different tools. We took a quick peek at Microsoft BI, R, Python, and ultimately decided to go with R in this situation just because of time constraints and personal expertise. Let's highlight that in quotes, of R. And the circlize package, which was used to form our chord diagrams, is very well documented, so that is always a plus. So just generally, circular layout is very useful to represent complicated and connected data. The circlize package in R actually implements a tool that was used in Perl, which is kind of interesting. And the chord diagram that we're about to show you today is just a small portion of the circlize package. I highly recommend, if you're interested in learning more and playing around of your own, to definitely check out the documentation at the end of the presentation. It's just amazing what this package can do, and we've barely touched on it here. So now I'm going to hopefully successfully switch over into a demo aspect. So hopefully you're all now seeing the R Studio window in your screens, crossing fingers. Someone yell at me if you're still seeing a PowerPoint.
We can see it, Jenny. It looks good.
Perfect. Okay. It's always a slight concern, right? So this is R Studio itself, and we'll just kind of be running just a small live demo here, hopefully successfully. So first off, we're just going to call the package. Once you've done a little bit of work in R, you'll realize this is kind of what you do at the start of anything. R basically runs off of its packages. And as you can see here, brief citation for this package. This is the paper that I refer to as well at the end of the presentation. Once again, highly recommend to go check it out. So just to start off, we are going to load that lump sum of a heat matrix that Laura had on the previous slide. However, as she said, how it had the duplicate relationships, we're going to pull that off so that we're only looking at an upper triangle matrix. We do not want to double count the publications within the cross collaboration. So for example, it had 14 publications between agriculture and arts, and we only want to count that once, not twice. So I'm just going to load in, and as we can see here, if we look at the matrix, we're not going to quite see it all together because it is a 27 by 27 matrix. But you can see the bottom values have been removed, and we only have the upper top of the matrix so that we don't have that deduplication. Okay, and then just to make sure I don't accidentally mistype anything, I'm going to copy paste these next couple of lines. This is just clearing the parameters, anything preset in the Chord chart that might have been used before. And then this one is just a very basic, if we don't implement this, the Chord chart would start at an 180-degree angle, but we want our data to start right at the top so we can kind of read it like a clock would. The gap degree is just simply giving us some space between our subjects for easy viewing. If you look at the Circos parameter values in the R documentation, you'll see so many different things you can do with your chart. So just keep that in mind. What we do is not what you need to do. It's just a good starting point. Now we're going to call the Chord diagram just with all of the data, no edits, no removal, with a low transparency setting just so that the graph isn't so, what's the word I'm looking for, brilliant in color, so to speak. We call that go. Now, just a note, a slight downside is that the visual, the Chord diagram in R doesn't always necessarily look the best. I highly recommend always pulling it out of R to actually use the visual itself. And I will go through that quickly after we're done. But there's just our starting Chord chart. You can see the values. Subjects start at that 90-degree area, and you read it around like you would a clock. This is using their colors, their process. And as you can see, it's a very pretty, interesting graph, but it's really hard to read at this point. You know, there's things all over the place. It's hard to see, clearly identify bigger relationships. So we're going to take a few different iterations of this to kind of get down to something a little more, I'm going to say readable, which isn't necessarily a word, but okay. So the first thing we're going to do is we're going to pull out any cross collaboration in between subjects that have 50 publications or less. So we're only going to see anything with higher numbers than that in this new one. Again, copy paste a couple things over to make it prettier. And at this point, since we are using the same parameters, we should be okay with our starting degree and our gap degree. And if anything goes a little weird, we can figure that out in a second. So calling the Chord diagram on the 51 publications or more. You can see on the right here, we got our next one. Once again, you know, compared to the previous one, we can just flip back here. You do see a reduction in some of those relationships, but unfortunately at this point, this is still hard to understand and interpret. So there's a couple ways that we can help make this a bit better to see and better to understand. One of them is subject grouping. So obviously, you know, this is just alphabetical at this time. But if we were to say, you know, take a look at this and you can see that computer science has some strong connections with engineering and math, which makes complete sense. So instead, if we were to group some of those common subjects together, we'll see those closer, bigger partnerships along this line, and then the more unique relationships will pop up across the graph, hopefully. So let's do that, taking the same data set and modifying the groupings. At this point, we're also changing the colors to reflect our faculty colors. So hopefully that anybody who's reading this graph will be like, oh, there's my engineering blue, and pop right to it. And sorry, most engineering is actually purple, wrong color there. So now you can see we have some of those like subjects grouped together. We have computer science and math into the sciences, into the engineering. So you're seeing some of those bigger relationships instead of necessarily crossing the graph. You're seeing them kind of doing these little arcs together. And then hopefully, as faculty members were to look at this, they could identify their subject matter a little easier going by the colors that they're used to. Now we're going to take this one step further, and we're going to go down to removing anything that's 100 or less publications together, just in an effort to even further see and understand those relationships. And copying and pasting so we don't have any errors. And this is a highly recommended aspect as you're playing with R or any software like this. Once you get something that you like, make sure you copy paste it somewhere else with some documentation so that you can repeat it whenever you actually need to again. You can save the R script within R, but it can be a little confusing when you go back and look at it, especially if you made a bunch of errors along the way. Definitely happened on the first time. So there we have the 101 or more publications between the cross subjects in a visual. So I am actually going to now go to my PowerPoint, or sorry, my PDF outputs of these, just because they are a little bit nicer to see. So as you can see instantly, when you output the R plots to a PDF, the clarity and it is just so much more clear to read. So this was our first one that we did with all the data points, nothing eliminated, no groupings, no colors. So still pretty wild, but really pretty still when you look at it. So as we go on, this was the less than 50 publications, still with no color or grouping. So, you know, a little bit more clarity, still not necessarily the best. Our iteration of having over 50 publications with the faculty colors, with the subject groupings, this graph is slowly becoming a little bit easier to interpret. And then last but not least, and I will just go to full screen mode to clearly see this, our final visual at this point, which is our over 100 publications between the cross subjects. And once again, you know, this really helped to clear up that not messiness, but the busyness of the middle. So here now we can clearly identify some of those big, maybe more common relationships, such as between engineering and physics, but maybe call out some of those ones that are not as common, like between engineering and sociology, or sociology and computer science, for example. So coming back to our PowerPoint. So this slide just kind of goes over a couple of those tips and tricks, and just kind of a reiteration that especially with these chord diagrams and figuring out your groupings and your relationships and your clutter, trying to clear that up a little bit. This is one of those things you're not going to just pop it in and be happy with your first iteration. You are going to repeat and retry. So recommendation, once again, about copying and pasting what you actually liked along the way, and it makes it easier when you go back again. So once again, the final visual currently as is. You know, that we are interested in exploring a few more things with chord charts here at the university. One thing that we're interested in is trying to look maybe at a trends over a year. So that data set was all for our combined 2015 to 2019. So instead, maybe breaking it down by year, say looking over the last couple of years and seeing how those collaborations change on a yearly basis. Which particularly might be interesting over our pandemic time here as well. We're also curious about benchmarking against other institutions and seeing how our cross collaboration and interdisciplinary work compares to them. And then finally, you know, our is good and it's useful and it's free, which is something I should also point out. But Python does have a bit of an edge where we may be able to make some of these chord charts a little more interactive, such as being able to select, say, that computer science and seeing and highlighting all those interactions against the others and iterating through the graph a little bit more. So we are also interested in exploring it through Python. We just have a bit more of a learning gap there as we get into it. And I don't know, Laura, if you wanted to add anything else to our next steps there, or if we're good to open to questions.
I actually did have something that we were chatting about while we were preparing for this presentation that I thought was interesting, was that Jenny had suggested maybe flipping the data. So instead of, you know, filtering by, you know, a minimum of 50 or 100 publications, maybe we look at those ones that have fewer than 50 or 100 publications in relation to each other. So, and see what that might be telling us. But yeah, I'm ready to open it up to questions now.
Thank you to both. We have a few questions, so I can just go through these, and we're actually really good on time. So thank you also for that. Let's see here. So one question that has come up. So like in thinking of these chord diagrams and these visuals, so at this stage, the question is, like, who have these been shared with at your institution, and what type of feedback have you received? So what kind of interest has popped up?
So the request was actually from our institutional analysis and planning unit to look at interdisciplinarity. So it was actually a really broad question. Can you just, you know, look at interdisciplinarity research? How can you look at that? And this was something that, you know, after trying things like looking at topics in topic clusters and SciVal and other, you know, data sets that might not be as readily available or easy to acquire, we thought that this was at least something that on a fairly short timeline could be compiled. Yeah, so it was through our institutional analysis and planning, and the interest there is sort of at the strategic planning realm of things. We just introduced last year our current strategic plan, so they're just sort of at an exploratory phase right now. I think that they yeah, just find this type of visualization really effective in bringing to sort of high-level meetings in order to, you know, see if there's more specific types of questions that people want to start asking, because, you know, as we all recognize, often this type of information can be easily misinterpreted, and it's also missing a lot of details. So I think that's where the institution's coming from, which is, I think, a healthy place to come from.
Mm-hmm. Okay, and Laura and Jenny, we've actually had 2 other questions arrive, and we definitely have time to get into these. So our first question is a comment plus a few questions. So fantastic work. Have you been able to see what kind of data is lost when you eliminate the collaborations that are less than 50 papers? And this first attendee says, for example, are any specific relationships possibly lost, or dynamic relationships, or that type of thing? So I don't know which of you would like to answer this question.
I can't answer that question because we haven't looked at it okay. In that much detail. But I mean, yeah, exactly. Like, okay, so we see a strong line between what do we see here, even like engineering and social sciences. Like every time I look at this data, it's like you see the visualization, but then you want to actually look into what are those actual publications really about, like what's happening with those. And yeah, I think, as I said, you could look at the opposite, what are you losing when you take those data points away? But no, we don't have answers to that question.
Okay. No
I
problem.
did want to just comment, sorry, that when we did go down and remove some of the publications, we did lose a couple categories. For example, veterinary is no longer on the final visual, which also kind of makes sense. Just as an institution, it's a smaller area for us. But yeah, I definitely think, that's kind of goes with our next steps about wanting to, kind of do the flip, do the reverse, and see what's those lower end collaborations and then what's going on there. And I think there's also, obviously, as Laura said, this is a very broad topic, a broad investigation, and I think it definitely opens the window to you look at this big overall arcing visual and you say, well, I really want to know some more details here, and maybe that's also where Python or some sort of more of an interactive visual that would let us dive into the smaller data and then visualize that from a click through would definitely be an interesting thing to explore.
Okay. So it sounds like there is a lot that can be explored. And what you were saying, Jenny, is that it's just, there are so many powerful visualization options, right? Like there's so much that you can do. It's just, I guess, the time.
Yeah, definitely.
There's another question, Jenny, for you. And the question is, can you explain how to connect the Chord chart paths back to included publications and authors?
Yeah, and it's kind of difficult at this point, as we said, because we took those lump sum high level aggregations and that's what we ran with. At the same time, I do think with some exploration through something like Python, we could drill down back into our data points. So we could actually, click on the computer science and drill back into those publications. It's one of those things, it would take a lot of work to implement. You'd have to load all your publication data into probably some sort of SQLite back database. And at some point you have to say, what's the question? What am I really interested in? Do I want to just be drilling down on the interactions of the publications in earth sciences? And in which case, okay, yeah, let's put the energy and just look at it from earth sciences point of view, as opposed to trying to do it for everything. I think would be the best at that point.
Okay, and one last question. Oh, we also have another comment. Just a brick attendee, just thanking you for the session, and just saying that they really appreciate what you've been sharing, and that your answers are very insightful and super helpful. But just the last quick question, actually for Laura, is you were talking about the process that you use to extract the 27 basically spreadsheets or data sets from SciVal for all the ASJC codes, the high level ones. Do you anticipate in the future, would you recommend going through that same process? Do you have any other option, for example, like using an API or anything like that? Or would you recommend the approach that Waterloo took, like that would be the best approach in the future?
It really depends on how much time you have, because like this was sort of using the tools at hand, right? While I was pulling this data, I was learning about SciVal too, and sort of like trying to flex its muscles and see like how much valuable data I can pull out of this system that we have access to without having to then, go back and use external tools to analyze the data. Like I think that if you wanting to do stuff like what Jenny's talking about, where you have a more interactive map, you would have to use something else, right? You would have to be basically starting from the publication line data and then using something to aggregate that data and do the counting and stuff outside of SciVal. But if you wanted to replicate exactly what we've done here, you could do that in SciVal pretty easy.
Okay. Well, thank you to both of you. Yeah, I know there's a lot of interest, so I wouldn't be surprised if you also hear back from some of the attendees, but thanks to you both.
Thank you.
Yeah, thank you for having us.
And so now we are actually moving into our last session on the program for today. And we also have two other returning great speakers